In this video, I will show you how to graph this logarithmic function. Let's start by simply graphing the parent function, which is just this part of it, without the horizontal shift or the vertical shift. So focusing on that part of it, then we should start with a table of values. The thing that makes graphing logarithmic functions different is that normally we start with the x values and then we find the y values that go with them. But for log functions, we actually start with the y values and then we find the x values that go with them. So let's start with the y values of -2, -1, 0, 1, and 2. We can just always start with those same 5 y values. Now let's find the x values that go with them. So looking at the parent function, y equals log x. And of course it's understood that there's a base 10 here, is the common log. If we were to rewrite this in exponent form, this would be we'd have 10 to the y power is equal to x. And this is the form that we will use to find all of these x values. Because what we're really doing is we're doing 10 to all of these y values. So 10 to the -2 power, 10 to the -1 power, 10 to the 0 power, 10 to the 1 power, and 10 to the second power. I always like to start from the bottom because the positive exponents are easier to see automatically. 10 squared is 100, which clearly will be way off the chart, but it's still good to have it on this table. 10 to the 1 power is just going to be 10. Anything to the 0 power is 1. Now these top two will just be the reciprocals of the bottom two. So this one will be 1/10, and this one will be 1/100th. Okay, so these are the values that go with the parent function. Now I think I will go ahead and write these in decimal form. So instead of having 1/10, let's go ahead and write 0.1. And instead of having 1/100th, that's the same thing as 0.01. Okay, that'll make it easier for what comes next. So now it's time to do the transformations with the +1 and the +5. So this is going to change the y value and the x value. So we'll have a new y value and we will have new x values. Okay, anything happening outside the function affects the y value. So this is a vertical shift. So this is going to wind up being y plus 5. Anything happening inside the function is affecting the x value. But remember, this is the opposite of what it looks like. So this is actually a shift left 1. So for that reason, the new x values will be x minus 1, not x plus 1. So if I add 5 to all of these values, I'm going to get 3, 4, 5, 6, 7. So these are my new y values. So now I need to subtract 1 from all of these x values. So this is just going to be 99 and 9 and 0. Okay, now these with the decimals, we will get -0.9 and -0.99. Okay, and if you need to, you can just do that on a 4-function calculator, even though you will not have a scientific calculator. Okay, so now we can ignore the blue values and we're just graphing the red values. Before we do that, let's pay attention to the asymptote first. Remember that logarithms have vertical asymptotes. And if there was no horizontal shift, the vertical asymptote would be the y-axis itself. So because of this shift 1 to the left, we will actually have a vertical asymptote at -1. So you should sketch that as a dotted line. So we will have this asymptote like this. Okay, so now we can go ahead and do the rest of the graph. All right, so let's see, 9, 6. Again, 99, 7 is way off the chart. So I'll just start with 9, 6, which would be about here. And then we have 0, 5 is going to be right here. And then we have -0.9, 4. Okay, so that's going to be here. And then we have -0.99, 3. So that's going to be so close to the asymptote that it's going to appear to be on the line. But we'll just have to know that it's really not. All right, so then you can just go ahead and draw a curve through these points as best you can. So that's going to look something like this. Okay, and the rest of this graph really should just trace this asymptote. Okay, or it appears to trace the asymptote. We know that it never really touches. Okay, so your graph should look something like this. However, in addition to simply being able to make the graph, you need to be able to answer questions like, what's the domain, what's the range, what's the asymptote, what's the x-intercept, and what's the y-intercept. Okay, so let's just answer those questions really quickly. So first of all, the domain. The domain goes from -1 to infinity, because it's from left to right, that's the x value. So -1 to infinity, make sure you use parentheses because the asymptote is never reached. The range. The range goes from bottom to top, so that's going to be -infinity to +infinity. Okay, let's talk about the y-intercept. Okay, well, the y-intercept is actually right on the chart, 0, 5. But in general, you can get the y-intercept by letting x equal 0. Okay, so in this case, if we let x equal 0, then we wind up with the following. We have y equals log of 1 plus 5. Well, what's the log of 1? Well, remember, the base here is 10. So what power turns 10 into a 1? 0. All right, anything to the 0 power is 1. So this is really just y equals 0 plus 5. So we get y equals 5. So if you couldn't just look at the chart and see the answer, you'd have to plug in 0 for x, and you could get it that way. But either way you want to think about it, the y-intercept is 0, 5. Okay, now the x-intercept is slightly more complicated. So for the x-intercept, instead of plugging in 0 for x, we have to plug in 0 for y. Okay, so if I put in 0 right here and solve, I'm going to need a little space for this. That's going to give me 0 equals log x plus 1 plus 5. So log x plus 1 plus 5. If I solve this for x, that's going to give me the x-intercept. So we'd have to subtract 5 from both sides. So we'd have -5 equals log of x plus 1. But then we would have to rewrite this in the other form. So this would be, remember that we have base 10. So this would be 10 to the -5 power is equal to x plus 1. And then we'd have to subtract 1 from both sides. So this will be x is equal to 10 to the -5 power minus 1. Okay? This is going to be x equals 10 to the -5 power is 1 over 10 to the 5th power. So this is like having 1 over 1, 2, 3, 4, 5. Okay, that's what we have. Now, 1 divided by 100,000 is 0.00001. So we have to take that and subtract 1 from it. So that gives us negative 0.99999. Okay, so that tells us the x-intercept. Okay, so the x-intercept is going to be negative 0.99999, comma 0. And I know it's tempting to round this to -1, but don't do that because that's the asymptote, and we have to show that we're not reaching the asymptote. The last thing you have to, speaking of the asymptote, you need to be able to say what the asymptote is. So the asymptote, of course, is the vertical line x equals -1. So please, in addition to being able to graph the function, you have to be able to state these 5 things. Hey, by the way, for that x-intercept, remember that we got it really from having 10 to the -5th power minus 1. I would have accepted this for the x-intercept. I would have accepted 10 to the -5th power minus 1, comma 0. I would have accepted that. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.